Okay, so what is a generalized Brownian motion is something like this. So if the dxt, or it's in short we write dx, if the dxt satisfy a dt plus b dwt, this format. Okay, so this dwt, the wt is the Brownian motion, so b is a constant, a is a constant. So if it is a dt plus b dwt, we call it a generalized Brownian motion. What is Ito process? If the dxt satisfy, it's almost same like a xt dt plus b xt dwt, it's almost same. Is the only difference is this a and b, this a and b is now a function of x and t. Okay, it's not anymore constant. This one is constant, a and b are constant. But in this case, if we consider Ito process, the dx is some function of x and t dt plus some function of xt dwt. Then we say this is an Ito process. Okay, initially we discussed the Ito process as integration formula. Okay, the ax equals to integration. So I think we don't really need the integration thing. So better I follow this formula. Okay, the differential formula. So the process for a stock price is, you always consider as a Ito process. Okay, ds is mu st. So if I write st here, so it's mu st dt. Okay, I just write in short. So we write ds is actually dst. Okay, it's a function of t. This one also function of t. So mu st dt plus sigma st dwt. Assuming the expected return. So how we write this one? So we have to assume these two things, the mu and the sigma. Okay, so assuming the expected return should be constant, so that means it's the whole thing mu is called the expected drift. If you divide by stock price, that part is a constant. So that part means mu s divided by s. So the mu is a constant, and there is always uncertainty. So if there is no uncertainty, means I think you mute your mic. I finish this one, then you say anything you want to say. You just speak at that time. So if there is no uncertainty, that means this part is not there. Okay, the Brownian motion, this part is uncertainty. So if there is no uncertainty, there will not be anything like this. Okay, so if but there is always uncertainty in the world. So we have second term is sigma s dwt. Okay, so the standard deviation of the change in a short period of time is proportional to the stock price. So we write it as sigma s. Okay, that's how we write ds equals to mu s dt plus sigma s dwt. Okay, we also follow this formula during the Black-Scholes method. Okay, when we discuss the Black-Scholes method, we also use this in dst. Okay, so okay, the Ito's lemma I have not discussed before. Actually, you don't really need this one, but this is the background how we do the thing. Okay, so I just mentioned the thing. So if a variable x follows the Ito process means this one. Okay, the dx equals to axt dt plus bxt dwt. So if there is a variable x which follow the Ito process, dx equals to axt dt plus bxt dwt, then gtx, g is a function of t and also function of this x. Okay, this x, then the gtx will satisfy dg equals to this plus del g del x b dwt. Okay, if even if you don't understand this one, it's doesn't matter. Okay, this one is just if you have a g function of tx, you use the Ito-Doeblin formula. So we have a del g del t, we have a del g del x. So del g del t dt, del g del x dx, dx is dwt. Okay, so dx, and then half del 2g del x2 dx dx. Okay, so we just write down these things, then we simplify the thing. We have dg equals to this one. Okay, something with dt plus del d del x dwt. Okay, so this one is actually Ito's lemma. So when I discussed this part, the log normal distribution, we actually didn't use the Ito's lemma. We just follow that if dst is something like this, dst is something like this, then we follow the what is the ds over s. We try to integrate, but the integration does not really so simple. So we use the Ito-Doeblin formula, then we found the thing. Okay, But the basic, if you follow the mathematical background, is actually the Ito-Doeblin formula, Ito's lemma. Okay, but anyway, this one is not so important. So you already know this one. You already know. We have already discussed. If G equals to log S, we can find out the del G del S, del G del T, del 2G del S square. Then the D of log X, we will have this form. Right? We have this form. Okay, this one we have already discussed in the class. So now if you try to integrate this thing, so you have a log S, maybe it is integration 0 to T, capital T. So this one also is integration 0 to capital T. This one also integration 0 to capital T. Okay, so you have something like this. So that means we have a log st divided by log s0. Okay, so this one is actually log st divided by s0. That means we have something like this, log of st minus s0. Sorry, log s0, log st minus log s0. Okay, so log st minus log s0. This one is something like a normal distribution with mu minus sigma square by 2t. This is the mean, and the sigma square t, this is the variance. Okay, so that's why we call this st is log normal distribution. Okay, so log s follows a generalized Brownian motion with constant drip rate mu minus sigma square by 2. Okay, if you follow the log s, okay, not the s. The s was mu. Now it's log s. Log s follows a generalized Brownian motion with constant drip rate mu minus sigma square by 2 and constant variance rate sigma square. The change in s between time 0 and time t is therefore normally distributed with mean, this one, mu minus sigma square by 2 capital T and variance sigma square t. Okay, so the log st you can write in this form. Okay, so this one you remember, I think, the expectation. Can you see this? The expectation e to the power ux. So if this x is a normal mu sigma square, then if you take expectation of e to the power some ux, we have shown in using the integration and all. You remember during the kurtosis, normal kurtosis, we have found this one, expectation e to the power ux. Before the moment generating function, we found this one. Expectation e to the power ux is equals to e to the power u mu plus half u square sigma square. Okay, you try to check the previous things. If you cannot really understand this one, I can do it again and then send to you. So using this expectation e to the power ux equals to this formula, we can find these things. Okay, so if log st is like this, then the expectation of st is like this and variance of st is like this. Okay, so you see, first, if you cannot understand this parts, I'll try to explain again later. Okay? So this is a thing, and then we have a distribution of rate of return. The continuously compounded rate of return per annum is normally distributed with mean mu minus sigma square by 2 and standard deviation sigma by root t. Okay, so there may be some question like this. We are given the mu, the sigma, and the time t. Then they ask you the continuously compounded rate of return. What is the distribution? So you just say it's normally distributed with what is the mean and what is the variance or standard deviation. And if they ask you the log normal distribution, you just say it's log s0 plus mu minus sigma square by 2t. This is the mean, normally distributed, of course, normally distributed with the mean log s0 plus mu minus sigma square by 2t, and the variance is sigma square t, or the standard deviation is sigma root t. Okay, very simple. Okay, the mu sigma t will be given, s0 will be given, so you just need to write down what is the distribution. Okay, two types. One is the this one, log normal distribution, the st. Another one is the expected rate of return. Okay, compounded rate of return. Okay. So I upload some questions on these, some tutorial problems, and then you try first. Then before tonight, I will solve and I will send a few hints. Okay, and then I hope these things. So put call parity, we already discussed multidimensional. Okay, so the risk neutral measure, I already recorded the video. I already have the voiceover. I recorded the whole risk neutral measure until the interest rate is BT. This one interest rate is RT, and then I mean not fixed interest rate. Okay, so far we are dealing with interest rate R. Now we have the interest rate is this one. Interest rate is RT. Okay, so the discounted process last time was e to the power minus RT dt, not dt, I mean e to the power minus RT, and then this time we have a e to the power minus integration 0 to t rs ds. Okay, so all these things I already explained in a video. All these things it's done. Yeah, until here, huh? Until here I already recorded. I sent to you. You see first, then whatever is your question, you either send me email, or better you just type in the TM, the Microsoft team, then everyone can see, then I explain. Okay, so any question? Any question? Try the video, you see if someone just not everyone, just someone try the video and see if everything okay. I am uploading in the WPLE. I mean link, posting the link. Okay, so maybe you see first the video and then wait for me to upload the tutorial question from the risk neutral, and then also the log normal distribution. Then you try to solve it. If anything you don't understand, you write here. Okay, you write here, or email, or the WhatsApp group. Anyone still not in the WhatsApp group? Then write your phone number here maybe, or some other way you just try to be in the group, then easier to communicate. Ah, okay, so working. I uploaded, I posted the link in WBLE. Still uploading, still updating. So wait for maybe another before Friday. Should be before Friday. I upload the latest version. I think we almost finished the things. So after that is just the forward. I think yeah, the forward and future only. I think we can. I can upload the. This is the latest version. This is the final version. I can upload the thing. I guess I can upload the thing. But anyway, I will create another maybe another 1 or 2 videos, at least 2 videos explaining the slide. So like the ITO integration, and then the Black-Scholes method, and then the forward and future contract. All these things I still need to create some videos. So wait few more days. Before Friday should be done everything. Then I upload the latest version of the slide. But the test 2, don't worry about the test 2. It's after 31st. We see how, and then even the final exam also, we still have the meetings and all. We are not finalized yet, so don't worry about those things now. Any more question? You can also speak now. I am not saying something, so you can speak. Okay. Anything? Otherwise, stop the recording first. We upload this in WBL, so no point we record conversation now. How to stop the recording?